Hello, Math Studies students. Let's take a look at our 5.4 notes, the chi-squared test. Okay, before we talk about what the chi-squared test is, let's talk about the symbol we use for chi. It kind of looks like a fancy capital X, and then of course we put an exponent of 2. That's how we will write the symbol we'll use for the chi-squared test. So what is the chi-squared test? The chi-squared test is a test that determines whether or not two sets of data are independent. So where one set of data does not depend on the other. So for example, suppose we survey 300 people and ask their favorite color of t-shirt. Now the data that we collect are called observed data. So this isn't anything calculated, it's just what's collected in a survey, or perhaps you could look it up in a published table, but it's just data that's observed. And it can be organized into what's called a two-way contingency table. And the table looks like this. So we have the colors of t-shirts, and then we have males and females that were surveyed. So this is our observed data, these numbers in white. Now these totals, they aren't actually part of the data. However, we'll use those totals later on when we look at some expected frequencies. Okay, so let's talk about the steps to follow when we conduct a chi-squared test. The first thing we're going to do is write what's called the null hypothesis and the alternative hypothesis. We indicate the null hypothesis with H sub O. The null hypothesis states that the data set, the two sets of data are independent. Okay, so then the alternative hypothesis states that the two sets of data are not independent. So step one is just to write down those two hypotheses, all right? And then step two will be to actually calculate chi-squared. Now, fortunately, in this course, we will let the calculator do that calculation for us and find that statistic. Okay, a couple of other values we need to think about. One is called the critical value, and the other is called the p-value. Now, let's talk about what those values mean. A critical value is calculated using what's called the significance level and the degrees of freedom. Good news for us, in this course, we will not ever have to calculate that critical value. That critical value will always be provided. So we don't have to calculate it, but I want you to think a little bit about what these two quantities, the significance level and the degrees of freedom, those are the two values that are used to calculate the critical value. Let's talk a little bit about what they mean. Okay, significance value is a measure of strength of the evidence that must be present in your sample before you will reject the null hypothesis. Now, what does that mean? Rejecting the null hypothesis means there is enough evidence to conclude your data sets are not independent. In this course, the significance level will be provided. Should you decide to perform a chi-squared test as part of your IA, then you will need to decide upon your significance level. Significance levels are usually either going to be 1%, 5%, or 10%. So what that significance level means, it's the probability of rejecting the null hypothesis when it's actually true. So obviously the lower the significance level, the better your conclusion is going to be, because it's less likely that you reject that null hypothesis, that the two sets of data are independent, when it's actually true. Okay, another value that's used in calculating that critical value is what's called the degree of freedom. Now, the degree of freedom would be the number of cells in the two-way contingency table that can vary. So let's think about it like this. So, for example, we had that table of, let's say you're going to choose a t-shirt color. You're going to choose a t-shirt color one day every day for 4 days. So on the first day, you would have four t-shirts to choose from. On the second day, you'd have 3 colors to choose from. On this third day, you'd have 2 colors to choose from. But on the last day, you don't have any freedom. There's only 1 color left, and so there's no freedom of color on that 4th day. So in other words, the degrees of freedom, what they do is they tell us how many of these cells can vary, and the way we can calculate that is we'll just take the number of rows the number of rows minus 1, and then the number of columns minus 1. Because remember, that last row or that last column, you only have one choice left, so there would be no freedom. So just take that number, take the number of rows minus 1 and the number of columns minus 1, and then you will multiply those. Now, in the chi-squared test, there'll be another value we may need to consider, and that's called the p-value. The p-value is the probability of evidence against the null hypothesis. Again, we won't ever have to calculate that p-value. We'll let the calculator do that for us, but there might be some times when we need to use that p-value for analysis. Okay, so then step 4 in our calculation or our chi-squared test is to use either one, and it doesn't matter, you could use one or the other, so either one of the following comparisons to make a conclusion. Okay, one of the comparisons that we could make is we could compare the chi-squared value that the calculator will give us to the critical value, and again, remember that critical value will always be provided for us. Okay, now, if the chi-squared value is less than the critical value, then we do not reject the null hypothesis. Okay? If the chi-squared value is greater than the critical value, then we reject the null hypothesis. Okay, so that's one comparison that we can use to make our conclusion using the chi-squared test. The second one is we could use the p-value and the significance level. So we will compare the p-value to the significance level. Okay, now, if the p-value is less than the significance level, then in that circumstance we will reject the null hypothesis. If the p-value, which remember was that probability of rejecting the probability that when we reject the null or rejecting a true null hypothesis, if it's greater than the significance level, that is when we do not, not donut. Let me fix that, sorry. That's when we do not reject the null hypothesis. Okay, I imagine your head is swimming by now, but I think we just need to look at some examples, and I think it'll start becoming a little more clearer for you. So let's return to our t-shirt example given above in your notes, and we're going to perform a chi-squared test. That chi-squared test will be performed at a 5% significance level, and the critical value is going to be provided as 7.815. So we're going to perform that chi-squared test to determine whether color preference and gender are independent or whether they're not independent. So the first thing we'll do is we'll write our null hypothesis. So the null hypothesis would be that the color choice of your t-shirt is independent of gender. So it does not matter whether you're a male or a female. It makes no difference as to your color of t-shirt choice. So that is our null hypothesis. So our alternative hypothesis is that color choice, well, you know what I'm going to do? I'm going to save some time here, because the only thing is we're going to negate this. We're just going to add the word not. So color choice of t-shirt is not independent of gender. Okay, so the next thing we'll do is we will let the calculator find our chi-square value. Now, down here I have all the steps, and when you get in class and you have a calculator, I want you to actually work through these steps and practice. And you'll find it looks like a lot of steps, but it's all menu driven and it's pretty easy after you've done it a few times. So we'll let the calculator do that for us, and that chi-square value turns out to be 33.8. Please remember to always write your answer to 3 significant figures. Okay, we were given the critical value. It was 7.815, and then the p-value will also be part of your chi-square calculation or part of your calculator work. That p-value turned out to be very, very tiny, 0.000002. Okay, that comes, so this value, the critical value, will be provided in the problem. The p-value, should you need it, you won't always need it, will be provided from your calculator. Okay, so now we're ready to make a conclusion. So let's do it two different ways. What you'll usually do is just compare the critical value. Oh, hold on. You'll compare the critical value to the chi-squared value. So let's do that. Let's make a comparison of chi-squared and critical value. Okay, chi-squared turned out to be 33.8, and the critical value we're given is 7.815. So you can see that the chi-squared value is greater than the critical value. So if you go back and look at your notes, you'll see that when chi-squared is greater, when the chi-squared is greater than the critical value, that's when we reject the null hypothesis. So our conclusion is we're going to reject the null hypothesis. And let's talk about what that means. Remember what the null hypothesis was? It was that the color of t-shirt is independent of gender. So if we're rejecting that, what we're saying, I'm going to say i.e., that means, that is to say, color choice, rejecting the null hypothesis means that color choice is not independent of gender. Okay? Now, just for the fun of it, we don't need to do both of these comparisons. You can do one or the other, but just for the fun of it, let's do our other comparison and see if we get the same result. So we're going to compare our p-value to the significance level. So let me write down what we're doing. We're going to compare p-value to significance level. Okay. P-value was that teeny tiny number of 0.0000002. The significance level, we were told, remember in the problem, our significance level is 5%. Now, if you're going to compare it to a p-value, which is a decimal, you need to turn the significance level to a decimal. So that's going to be 0.05, 0.05. All right, and so we can see that the p-value is clearly less than the significance level. So if you look back at your notes, when p-value is less than significant level, that is when we reject the null hypothesis. So you'll see that it doesn't matter which comparison you do, chi-squared to critical value or p-value to significance value, you'll get the same result. Okay, let's talk about expected frequency. So expected frequency is when we multiply the probability of two independent events. We'll talk about how to do that in a second. So we take the probability of two independent events and we multiply it by the total number of participants. So let's talk about how to find the probability of independent events. You may have studied this in a previous course. If we have two events that are independent of each other, and we want to find the probability of both of them happening, of A and B, then we simply take the probability of the first event and we multiply it by the probability of the second event. So let's find the expected number of men who like black t-shirts. So we're going to find the probability of A. That would be, our first event would be the probability that a person is a man. So the probability that we're talking about a man. Okay, so if we go back to the table, let me scroll up there. Let me find that table. So the probability of a male, well, we have a total of 150 males out of a total of 300 people. So the probability of being a male is 150 out of 300. Now, if you want to write 1/2, you can. I'm going to go ahead and write 150 out of 300 so you'll remember where these numbers came from. Okay, then the other probability we need to look is the probability of a person, either man or woman, choosing a black t-shirt. So again, looking at the table, the total number of people that chose black t-shirts, there were 83 of them out of 300 people. Okay, so that would be 83 over 300. So the probability of A and B would be, remember, you got to multiply those two probabilities together. So that would be 150 out of 300 times 83 out of 300. So that's the probability of person being a male and a person choosing a black t-shirt, but then remember to get expected frequency, we need to take that probability and we need to multiply it by the number of participants. So there were 300 participants, so we'll multiply this by 300. So you can see that some things would cancel. So when you calculate on your calculator, you should get 41.5. Well, 41.5 can't be the number of men. You can't have a half of a man. So we could either say either 41 or 42. I think either of those answers would be acceptable. Usually you round up, but it's okay to round down in this case. Okay, let's try that one more time. This time let's find the expected number of women who like red t-shirts, okay? So the first thing we need to do is calculate the probability. That would be the probability that the person you choose randomly is a woman and likes red t-shirts. So taking those one at a time, the probability of choosing a woman at random would be there were 150 women out of 300. Again, these numbers are coming from the table, okay? The probability of a person choosing a red t-shirt, that was a total of 75 people liked red out of 300. So the probability of being a woman and choosing a red t-shirt would be the product of those probabilities. So 150 times 300, or over 300, times 75 over 300, and then you multiply that by the number of participants, which is 300. So again, you could reduce these fractions and make the arithmetic a whole lot easier. You'll probably use your calculator anyway, and we get 37.5. And again, you can't have a half a woman, so we could either say 37 or 38 women. If you choose one randomly, the likelihood that that would be the expected number of women who would like red t-shirts. Okay, we're going to work through a couple more examples just because I want you to get familiar with the process. The calculator work you can worry about later. Like I said, it's not very hard. It's menu driven and you'll get used to it really quickly. But you need to get used to actually performing this chi-squared test. So let's look at this example where we have 100 people interviewed outside of a chocolate shop to find out which flavor of chocolate cream they preferred. The results are given in the table classified by gender. So here are our results. Again, remember, we're just looking at the observed data right here for the moment. Okay, these totals you don't want to include for certain things. Okay, so we're going to perform a chi-squared test at 5% significant level to determine whether the flavor of chocolate cream is independent of gender. Okay, so the first thing we're going to do is state the null hypothesis and the alternative hypothesis. So for letter A, we're going to say that H sub O, our null hypothesis, is that flavor choice is independent of gender. And then our alternative hypothesis is that, well, you know what, let's just do this. Flavor choice is not independent of gender. Okay, so that's letter A. Letter B then says, show the expected frequency for female and strawberry flavor is approximately 16.3. So let's find the expected frequency of how many times, if you choose a person at random, how many of those would be female? Well, not choosing at random, it's not a probability. How many do we expect? How many females like strawberry? So we need to find our two probabilities. The first probability is the probability that the person is a female. Well, there were how many females? If you look back at the table, there were a total of 43 females out of 100 people. So that probability is 43 out of 100. Okay, then let's find the probability that a person likes, oops, not red, I'm thinking about the last example. What is it? Oh, strawberry. The probability that a person likes the strawberry cream, and that sounds good. Okay, so if you look at the table, there were 38 total strawberries out of 300 total, out of 100 total. So that would be 38 out of 100. Okay, so to find that expected frequency, we'll take the probability of A and B, we multiply those, 43 over 100 times 38 over 100, multiply it by the number of people, that was 100 participants, and that turns out to be 16.34. So yes, that does agree with the fact that expected frequency is about 16 people. Okay, letter C says find the degrees of freedom. So if you look at, now make sure that you are looking at just the observed data. So that would be this part of the table, okay? Don't include the totals. So you need to count the rows and you need to count the columns. And you'll notice that there are 2 rows. There are 2 rows and there are 4 columns. So to find the degree of freedom, we take the number of rows minus 1 times the number of columns minus 1. So that is what? 2 times 3. So that turns out to be 6. Okay, the next thing we're going to do is write down the chi-squared value for this data. That's done on the calculator, so you'll practice that in class, and when you do, you'll see that chi-squared turns out to be 6.88 to 3 significant figures. So now we can make a conclusion. So if we're told that the critical value is 7.815, let's use the critical value or the p-value and then comment on the results. So you can do either one. I'm going to just do both one more time just so you can see both, but obviously you could use either to make your conclusion. So let's compare critical value to, the chi-squared value to critical value. So we're going to compare chi-squared to critical value. Okay, the chi-squared was 6.88. The critical value was given to us. Remember, it's given here, 7.815. And 6.88 is less than 7.815. So therefore, we do not reject the null hypothesis. So what does that mean? The null hypothesis said, it said that flavor choice is independent of gender. Okay, we're not going to reject that, so that means we're going to, so we can conclude the following. We can say, therefore, there is enough evidence to conclude that flavor is independent of gender. So there's not necessarily, or doesn't appear to be, a relationship between flavor choice, and I should have said flavor choice here, flavor choice. Okay, flavor choice and gender. Okay, let's go ahead and look at one more example. This one says members of a club are required to register for one of 3 games: billiards, snooker, whatever that is, or darts. The number of club members of each gender choosing each game in a particular year is shown in this contingency table. Now you'll notice that what is not included in this table is we don't have the totals. So we might want to go ahead and just add those totals because we're going to need them later. So if we total each column, we would get 60 and 30 and 25, and then total each row, we get 63 and 52, and then the grand total of people would be 115 then. Okay, so what we're going to do is we're going to perform a chi-squared test at the 10% significance level to determine if the chosen game is independent of gender. So you might have a suspicion how it's going to turn out. Let's see if the math backs up your suspicion of what you think is true. So the first thing we're going to do in letter A is we're going to state the null hypothesis, and we're going to state the alternative. So the null hypothesis would be choice of game is independent of gender. So then the alternative hypothesis would be that choice of game is not independent of gender. Okay, so that was letter A. Letter B says, show that the expected frequency for female and billiards is approximately 27.1. So let's do that again real quick. Probability of a person being randomly chosen being a female would be, there's a total of 52 females out of 115 people. Okay, the probability that of a person choosing, billiards. Again, use the table. There, the total number of people who chose billiards was 60 out of 115 people. Okay, so we take those two probabilities. The probability of A and B would be 52 over 115 times 60 over 113. So this represents the probability of A and B, and then we multiply that by the number of people. Oops, this should be a 5, sorry about that. Multiply that by 115 people, and the result, if on your calculator, does turn out to be 27.1, so that checks. Okay, then in letter C, it says write down the number of degrees of freedom. So for degrees of freedom, we take the number of rows minus 1. There are 2 rows, times the number of columns minus 1. There are 3 columns, and that would be what? 1 times 2, which turns out to be 2. Okay, letter D says write down the chi-squared value. Again, you'll do this on the calculator. Chi-squared to 3 significant digits turns out to be 7.79. So now we're ready to make our conclusions. Let's just do the one comparison this time. We're going to compare chi-squared to critical value. Okay, so let's compare our chi-squared value to the critical value. Okay, our chi-squared was 7.79. We got that from the calculator. The critical value is provided in the problem. That is 4.605. Well, 7.79 is greater than 4.605. So that means we will reject the null hypothesis. So what does that mean to reject the null hypothesis? Well, the null hypothesis was that the choice of game was independent of gender. So we can conclude, we can say, therefore, there is enough evidence, okay, against our null hypothesis to conclude that choice of game is not independent of gender. That's kind of what I thought. I wonder if you all suspected that as well, of gender. But now we have proof that our suspicions were true. Okay, and then last but not least, if you choose to perform a chi-squared test as part of your IA, you will need to use the following formula to actually calculate the value of chi-squared. We're going to let the calculator do it for us for homework and tests and quizzes and for your papers in May. But if it's part of your IA, here is the formula. And it looks kind of complicated, but it's not that bad. To find chi-squared, you're just going to take the sum of a bunch of ratios. Those ratios will be, the numerator will be f sub o minus f sub e, so that would be observed frequencies minus expected frequencies. So you'll subtract those and square it and put it over the expected frequency. So you'll just add up several ratios, and that's the calculation that you will use if you need to do so in your IA. Okay, so I encourage you when you get in class and you have a calculator to go back and with these notes and work and practice getting that chi-square value on the calculator just for practice, and then we'll do these problems in class. If you have any questions, be sure and let me know.